Hi there, Algebra 2. 6.2, multiplying and dividing radical expressions. Objective, students will be able to multiply and divide radical expressions. Vocab, simplest form of a radical just means simplifying a radical so that there are no more square roots, no cube roots, no fourth roots, etc. left to find. It also means removing any radicals in the denominator of a fraction. Rationalizing a denominator is the last part of the last definition. It means to eliminate any radical expressions in the denominator such as a square root and cube root, and etc. Alright, so today, combining radical expression products. So if I take nth root A and nth root B are real numbers, then nth root A times nth root B can be multiplied together because of the fact that they would both have the exponent of 1n. Alright, so can you simplify the product of the radical expression? Explain why if you can. Okay? In this one, we should write this as a fraction. What that 4 stands for is 7 and 1/4. That's how you'd write that as an exponent. Now this one would be 7 and 1/5. Okay. The only way, our bases are the same. I agree with you 100% on that. But you cannot combine these unless these are the same when you have fractions in your exponents. As long as your fractions are not the same, you cannot. So, can you simplify this one? No. Because the exponents are different fractions. Alright, now this one, they are the same. So now you can multiply these two together. And when you multiply these two together, you're going to get -5 times -2, which is going to get you a positive 10. And that's going to be the fifth root of positive 10. There is your answer for a problem like that. Alright, simplifying products. Simplifying products. What is the simplest form of the third root 54x to the fifth? Okay? We need to break this down, and I do this a couple different ways. The one way that I do it, I think, is a lot better for you that struggle seeing this. I need to break this down or factor this down so that I can get groups, and this 3 tells me I need groups of 3. So I'm going to take a 2 out, which is going to give me 27. Alright, out of that I'm going to take a 3 and a 9. Alright, 3 can't go any farther down, so I'm going to go 3 and 3. Alright, now I'm looking for groups of 3. I found a group of 3. I can only take one of those out of that group of 3, and it'll represent that. So I'm going to get 3. Okay? Same thing with the x's. You can think of two things about the x's. You can write this as the exponent way, which would be 5 over 3. And you can see that you can take 1, you could end up doing this like a mixed number. So then you get x to the first, and you get x to the 2/3. Okay, obviously the x to the first can be pulled out. Otherwise, if you're really onto that group thing, we have 5 x's here. Take a group of them. Okay, so I have a group of x's too. Can't take any more of that. So the rest of this has to stay in this cube root. So we have to leave a 2 in there. We have to leave 2 x's in there, which is x to the second. That is my answer. Like I said, there's a couple different ways. I usually break it down like this because there are students that do not see this. Alright, same thing with this one. I'm going to break down 128. I'm going to go 2. 2 is probably going to be 56. No. Would have to be, 2 goes in there 6. It'd be 64. Alright, take another 2 out of there. I'm going to get 32. Take another 2. I am going to get 16. I'm take another 2, 8, another 2, 4, 2, and 2. Alright, I got one group of 2s. I got 2 groups of 2s. I get 1 out of each one of those. So I can multiply 2 times 2 and get 4 again. Alright, can't do anything with this cube. Now, if you're really good, you might know your cube roots. And we are going to go through those here in a little bit. When you know your cube roots, you find numbers that work, and you're going to just say, okay, I know the cube root of that, therefore I'm done. Can I do anything with that number left? 64 is a cube root of 4. Alright, so we could have been done right at that point. Obviously, we showed that. Okay, now our x's, once again, you could go groups of x's, so we have x, 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 and x. Okay, because I got 7 of them. Group of 3, group of 3. So I got 2 groups of 3. So that means I got x to the second. Alright, leaving me the square root of 2x. There's my answer for that one. Like I said, might not be the quickest way, but for a lot of you that don't see it, I think it is probably the best way visually to do it. Alright, now we have to multiply before we even do that this time. Let me get this erased so we can see what we're doing. Alright, now you could take the square roots before you even do it and see what happens. I'm just going to jump in and I'm going to say, I'm going to multiply it all by, or together, and then work from there. Alright? So, on this first one, I have 720x to the 4. So I multiplied this times this. That's 720. Combine these, we're multiplying, so the exponents can be added together. Here's y, and y to the third. So we have y to the fifth of those two, right? We're taking the square root. So we're looking for groups of 2. Alright? Now, myself, I know that in 72, 36 comes out of that. But I'm going to take 36 out of there, which is actually going to leave me with 20. Alright, excuse me. We would have 4 and 5. Okay, I can take the square root of 36, I get 6. I can take the square root of 4, and I get 2. I cannot take the square root of 5, so that's going to have to stay in the square root. Okay? Now we have x times x times x times x. Alright, one group, 2 groups. So that's going to leave me with x to the second. Alright, y's, we have 5 of them. Y times y times y times y and y. Group of 2. Group of 2. I have 2 groups of 2. That means that's y to the second. Okay, what has not been circled? Well, that is going to be my 5, because I square root of both of these. I'm going to get 5 and a y. Well, I'd have to multiply these together. 6 times 2 is 12. There you go. That would be the answer for that one. Alright, let's go to the next one. What is the simplest form of this? This one's a little bit more difficult. I'd probably multiply it together again. Why? I don't know. I like the challenge, I guess. Alright, so we got 45 times 35. which is going to give me 1,575. All right, we're multiplying our x's, so we can have the exponents. Well, this is the first, this is the fifth, so we're going to get x to the sixth. We got y to the third and y to the fourth. That's going to give me y to the seventh. Now we're going to take the square root of that. One thing about it, I see a 75 at the end of this one. It's ending in a 5. I'm going to take the shot that probably 25 goes into that. Alright, 25 I know is a perfect square. That's one of the reasons I used it. I get 63. I'm going to go 3, or not 3, I'm going to go 9 and 7. Okay, I know 9 is a perfect square, so I'm going to pull them out. Take the square root of 25, I'm going to get 5. Alright, take the square root of 9, I'm going to get 3. So I can come out of the square root. Take the square root of 7. Can't do it. Okay, I've got x to the 6, which is really x 6 over 2. Reduce your fraction is another way to do this. I'm doing it the other way. So maybe you start seeing that. So this would be x to the third. That means it comes out perfectly. I got rid of my square root by simplifying this. I have y to the 7 over 2. Well, 3 times it can go in there, leaving me 1 left, right? Okay, I couldn't do the 7, and I have 1 y left. There's the answer for that one. All right. Combining radical expression quotients. So now, instead of multiplying, we're going to be dividing. All right, we have nth root of a over the nth root of b, which is actually the same as the nth root of ab. Because you can break it down and write it the same way. Okay? All right. The one thing that I think we said right off the bat is you cannot have a square root or cube root or radicand in the denominator. So I have to multiply the bottom by something that will make this happen. Can we take the square root of 2? No. But if we times 2 by 2, we're going to get 4. We can do that. X to the third, it's odd. This is to the second, so the only way to get rid of it would be another x, because then we get an even number, which any even number will work. What do I do to the bottom? I also do the top. Okay? So realistically, here on the bottom, I'm going to end up with 4x to the fourth. All right, up top, we're going to end up with 36x to the sixth. All right, take the square root of 4, you're going to get 2. Take the square root of x to the fourth, which should be x to the second, because you'd have 4 over 2 as your fraction, which would just be 2 by simplifying it, which would then would get rid of this. All right, top, we're going to do the same thing. Square root of 36 is 6. Square root of x to the 6 should be x to the third when I simplify my fraction in my exponent. All right, this one, we just have to multiply by the square root of 2. Because x to the fourth square root will work. All right. What do I do to the bottom? I must do the top. I'm going to end up getting 4x to the fourth, square root. It's going to be 100x to the sixth. When I simplify this, on the bottom, I'm going to get 2x to the second. The top, I am going to get, well, the square root of 100 is 10. Square root of x to the sixth is x to the third. Answer. We could reduce both of these down now that I think about it. All right, what can I reduce this down to? Well, 6 divided by 2 is 3. When we have same bases, we subtract the exponents, that's just x. There's actually my answer for this one. This one, I can take a and divide 10 by 2, and I should get 5. Subtract my exponents, my answers. That would actually be the simplest form, and I apologize that I forgot about that. All right. There is that. Got a slide. Just one slide left. All right. So, what is the simplest form of this? Obviously, we're doing the exact same thing we had been doing, only it's a touch harder. Okay? So, to take the cube root of this is when I did the chart for them today in class. The cube root, to get 1, if we take the cube root of 1, we're going to get 1. Okay? To get equal to 2, we have to take 2 times 2 times 2, which is 8. Get rid of that. Alright, 3 times 3 times 3 is going to give me 27. That is the cube root is going to be 3. Alright, 4 is going to be 64. Is going to be the cube root. 5, the cube root is going to be 125 equals 5. 6, I believe is 216. Yes, 216. It's 343. That's the 7th. The 8th is 8 times 8 times 8 times 8 would be 519 is going to be your 8th. 9th, obviously you should know your 10th, which would be 1,000 if you didn't know. So, I would write these down somewhere. It makes life a lot easier. Okay? So, 12 here. I'm going to look for something that works with 12. Multiples would be some things that could go in there, 2, 3. But I don't think I can make it to 8, and I don't believe I can make it to 27. 4 goes in there, but 12 doesn't go into 64, so I know I can't quite make it into that. 5 doesn't work. 216, let's check that. 216 divided by 12, 18 times. So we'd have to take the bottom times 18 to get 216. Alright, we gotta have 3s. So this is only 2, so I'd have to multiply by y to the first to get that to be y to the third. Alright, z to the second is what I need to get that to the z to the third. What I do to the bottom, I must do to the top. Alright. Bottom here, we're going to get square root of 216, or cube root, my bad. Cube root of 216. You're going to get y to the third, z to the third. And up top, you're going to get 5 times 18, which is 90. X to the second, y, z to the third root, or the cubic root. Alright. The bottom, we already talked about this. We see that's 6. Alright, here it'd be y, and it'd be z. Up top, square root of 90. It won't work. Factors of 99 and 3, which is going to end up getting me, or not 9 and 3, 9 and 10, which is going to give me 3 times 3 times 2 times 5. None of them is a group of 3, so the 90's got to stay inside there. X to the second isn't going to come out of there. Y by itself isn't going to come out of there, and neither is z. Answer. Okay? here, we need the third. I feel like we gotta get to 125. 5 times 25 is gonna get me there. Alright, gotta have a y in the bottom to get this to y in the third, so I can take the cube root of it. Cube root, must do the same to the top as I did the bottom. I am going to get the cube root of 125 y to the third on the bottom. Top, I'm looking at the third root of, that must be 175 x y. Alright. We know that the cube root of this is going to be 5. We know the cube root of this should just be a y. Doing the top here, this is 5 and 5, and this is 7. I don't got a group of 3. So I'm going to have to leave that. Alright, and my x isn't going to be able to come out, and neither is my y. Answered. Alright, you have a worksheet for your homework. Not actually what's on this slideshow. You have a worksheet. You already have that assignment, so you should be good to go.